You might have heard the word titration before. Titration is a reaction in which a substance in a solution of known concentration. So you have one solution of known concentration, known molarity, for example. It is reacted with another solution with unknown molarity. And usually the purpose of acid-base titration is to find out this unknown concentration. Okay, usually it is to find out the unknown concentration. So how does a titration work? In this example, hydroxide ion is being discharged from a burette. How can you discharge hydroxide ion? What this means is this burette contains a solution that has hydroxide ion. So this solution could be a sodium hydroxide solution or potassium hydroxide solution or lithium hydroxide solution, right? Any solution that has a hydroxide ion, and it's the hydroxide ion that is being shown in the burette. Now in this Erlenmeyer flask, we have an acid solution which contains the H plus ions. Okay, this is any acid solution that contains the H plus ions. What the idea is that this is the reaction that's being studied. And what does this reaction tell you mainly? If you look at the stoichiometry of this reaction, 1 mole of H plus is required to react with 1 mole of OH minus, right? So every time an OH minus comes in contact with an H plus, a water molecule is formed, right? So here we have 1, 2, 3, 4, 5 moles of OH minus shown here, and here there is 5 moles of H plus. Okay, so then what happens is every time an H plus comes in contact with OH minus, a water molecule is formed, and then after all the 5 H pluses are completely used up, what happens next is that once the OH minus comes in here, there is no H plus for it to react with. Along with the acid, in this bottle, in this flask, there is another substance called the indicator. The speciality of this indicator is that it shows different colors in acid and base environment. So this indicator that we used in this particular example is colorless when it is in H plus environment, H plus rich environment. But when all the H pluses are exhausted, the minute an OH minus comes in here, there is no H pluses for it to react with, and so this solution becomes basic because there is an OH minus in there and there is no H pluses in there. In the basic environment, the indicator changes color to pink. So that means once that extra OH comes in, you will see that the color of the solution changes from colorless to pink. The other information that you will get when the solution turns pink is that all the acids are used up. So acids are the H pluses are completely used up. And this is an actual titration of sodium hydroxide with HCl solution. So there is HCl solution and phenolphthalein indicator in this Erlenmeyer flask, and OH minus is being discharged from the burette. So this information, the amount of liquid that has been discharged and the amount of liquid that you have here and the concentration of solutions available will give us quantitative information about the unknown concentration of the solution. And we will work on problems.